Okay, so example one, if you guys want to pull out that sheet that you have with all the word problem examples, we're now going to start with number 18. So that'll be our first example. And again, the directions are just going to say solve. So our first one is a cereal is made by mixing oats costing $2 per kilogram and fruits and nuts costing $9 per kilogram. How many kilograms of each are needed to make 60 kilograms of cereal costing $3.75 per kilogram. So if you've ever wondered why there's so little fruit and nuts in your fruit and nut cereal and there's so many flakes, this is the reason why. It's so much cheaper for the oat flakes than it is for the fruits and nuts. So in our chart, our unknowns are going to be oats, fruits and nuts, and we're going to call the last guy mixture. And across the top, we're going to have amount, and in this case, we're measuring in kilograms. We're going to have cost per kilogram, and then we're going to have total. And then we just start putting data in that we find in the problem. So cereal is made by mixing oats costing $2 per kilogram. So we know what he is. With fruits and nuts costing $9 per kilogram. So we know what he is. And how many kilograms of each are needed to make 60 kilograms? So that's what we want to end up with in our mixture, costing $3.75. So this one I can get the total in right now. The problem comes in that we don't know either amount. So here's what I'm going to do. We already have one example from the last set of notes in which we used two different variables. So I wanted to give you one where we used one variable. If one amount is x and the total amount is 60, how do I define the second amount? True? That's your 60 minus x. Okay. So total is going to be 2x. Total here is going to be 9 times the quantity 60 minus x. And because I only have one variable, I'm just going to take and do one equation. So that one equation is going to be 2x plus 9 times the quantity 60 minus x equals the 3.75 times 60. Now, there's only one decimal right now in the problem. So what I'm going to do is, since I notice the number I'm going to multiply the 3.75 by ends in a 0, I'm going to just see if maybe if I multiply those two, would the decimal disappear altogether? So I get a 0, I get a 30, 42, and 3 is 45. 18 and 4 is 22, 2 digits after the decimal point. Sure enough, it goes away. So what I'm not going to do is I'm not going to multiply by some power of 10 to get rid of the decimal, because just the multiplication alone will make it all go away. Okay, so here we are at 2x. Now I'm going to distribute 540 minus 9x equals that 225. So I'm going to subtract the 540 from both sides. Now I'm going to put it up on top so I can do the subtraction a little bit more easily, and then combine up 2 and negative 9x for a total of negative 7x. So when I do the subtraction, over here, I'm going to have to do some renaming. So I'm going to take 1 away from here with a 3. That becomes a 10. So 10 take away 5 is 5. 3 take away 2 is 1. 3 take away 2 is 5. Oh, sorry, 3. Hello. And that's negative because that 540 was negative. So now we divide both sides by -7. And the two negatives cancel. 7 goes into 31 4 times, which is 28 with 3 left over. And 7 goes into 35 5 times. So what that tells me is that I'm going to get 45 kilograms of oats. To figure out how much with fruits and nuts, I'm just going to plug it into the definition and subtract 45 from that, and I get 15. So I get 15 kilograms of fruits and nuts. Okay? All right, next problem. Number 2, which is off your ditto number 19. This question answers, why in the mixed can of peanuts or nuts is it always peanuts left when I get there? Because that's what they put the most of in there. Why? Because he's the cheapest. Okay? He's actually the worst kind of nut for you, too. Peanuts sell for $3 per kilogram. Cashews sell for $6 per kilogram. How many kilograms of cashews should be mixed with 12 kilograms of peanuts to obtain a mixture selling for $4.20 per kilogram. So sometimes our mixture is driven by how much we want to charge. Okay. So we've got two types of nuts. We've got peanuts and cashews. Oops. And we always end up with a mixture. We have amount, which again is in kilograms. Bless you, bless you. We have cost per kilogram. And then we have total, or total cost. So looking through here, we know the cost of peanuts is 3. The cost of cashews was 6. And then it says how many kilograms of cashews, so he's X for amount, so his total amount would be 6X, should be mixed with 12 kilograms of peanuts. So it tells me exactly how much I have in the way of peanuts. So the total is going to be 3 times 12, or 36. And it says to obtain a mixture selling for $4.20. Now I don't put in that extra 0 because he's not going to come into play with the multiplication. So what do I write for the amount in the mixture? Yeah, it's the two quantities added together. So then I get 4.2 times the quantity 12 plus x. So again, where I look for my equation, since I have one unknown, is from that total column. So I get 36 plus 6x equals 4.2 times the quantity 12 plus x. Now in this situation, I only have one decimal, but when I multiply 4.2 by 12, it's not going to make the decimal disappear. So I am going to multiply by a value that has 1 0 to get around that one digit. So I'm going to multiply everything by 10. So that brings me to 360 plus 60x equals 42 times the quantity 12 plus x. So then I distribute, and I don't know what 42 times 12 is, so I just do it off to the side. And what you are never going to see me do is erase my work, which I don't know why some of you think you need to. It doesn't make it neater, it makes me confused how you got your answer, plus 42x. So now I'm going to go ahead and subtract 42x from both sides, and I'm going to subtract 360 from both sides. That way I get variables on the left, constants on the right. So this gives me a total of 18x equals 144. Divide both sides by 18, and we get x equals 8. There's only one question I'm being asked to answer, and that's how many kilograms of cashews. So I could leave my answer just as 8 kilograms, or I could say of cashews, and then box it up. Okay. Now I'm going to do this a little out of order because the question 20 is a departure from what we're used to. So I want to do 21 first. So in the hard copy of notes online, you'll see this being question 4 as opposed to question 3. So this one is a liquid problem, but there's no percents in it. It's about a grocer who has 2 different types of juice and he wants to make a blend, and then he wants to figure out what to charge people for the blend. So a grocer mixes 15 liters of juice worth 45 cents per liter with 10 liters of juice worth 60 cents per liter. How much, not mush. How much should he charge per liter for the mixture? So again, a grocer mixes 15 liters of juice worth 45 cents per liter with 10 liters of juice worth 60 cents per liter. How much should he charge per liter for the mixture? All right, so I'm just going to call them juice 1 and juice 2 since they really didn't distinguish the kinds of juices. They didn't say like apple and cranberry. You could call it juice A, juice B. Oops, there I go, changing my idea here. And then we've got the mixture. And then we're going to have amount, which is in liters this time. Helps me track my labels. And cost per liter. And then we have total cost. So what's interesting about this problem is it blatantly tells me information. It says, hey, he's mixing 15 liters of a juice that's worth 45 cents. So I get 0.45 times 15 for the total of that first juice. The second juice, he's blatant. He says, hey, you got 10 liters of a juice that's worth 60 cents. So I get its total is 0.6 times 10. Now I could multiply that out, but I'm not going to. And then there are no more numbers given in the problem. But we need to fill in amount and cost per liter for the mixture and therefore come up with its total in order to come up with our equation. So how much is in our mixture?
25 liters.
That's right. We've got the 15 from the first juice, the 10 for the second, for a total of 25. How much is our mixture going to cost? That's what we're trying to solve for. That's your x. So we get 25x. So again, no surprise, the equation comes from this line right here. So I'm going to do this a little differently. Since the only place x shows up is in the mixtures total, I'm going to put him on the left. And he is going to be equal to the sum of the other two. Okay, now, you might say, you know what, if I multiply 0.6 times 10, I'm going to get rid of the decimal just naturally, but you're not going to get rid of the decimal with the 0.45 times 15. So I'm just going to multiply everything by 100 to get that decimal point to go away. So that leaves me with 2500x equals 45 times the quantity 15 plus 60 times 10. So I get 2500x equals, and then 45 times 15, I don't know. So 25, 22, placeholder 54, 675. So I get 2500x equals 1275, and then I divide by 2500. Now, because the answer is supposed to be dealing with money, there's no way to write this answer as a fraction. So we're going to have to do some long division. How many times does 2500 go into 1275? Well, it can't go in at all, so that's when I put in a decimal point and then add a 0. So 2500 can go into 12,750. 6 is going to take us well over the 1200. So let's try 5. And that's going to give us 0, 0, 25, 12. Jacob, can you get that and just say, I'm in the middle of that. Thanks. I'm going to bring down another 0. And look at that. That goes in evenly. What if it didn't go in evenly? What would we do?
Stop it. Stop after. Round it.
Yeah, we'd have to go one more round. And then we'd have to round up to the nearest penny, because that's where money goes. So what we get is 51 cents would be the cost. Okay? Okay, perfect. All right, let's do that last problem, that weirdo. And this is the one that deals with a whole different equation. But it relates back to something we did in Chapter 5 and in Chapter 8. So Tom travels 4 hours at 80 kilometers per hour and 1 hour at 40 kilometers per hour. What is his average speed for the whole trip? Now, I've seen this question show up, not this exact one, but something similar, CSTs and the high school final. Because kids think there's an easy way. They see the word average, and they say, oh, I'm going to add up the speed and divide by how many speeds I added up. Bam, I got an answer, 60. And I'll guarantee you on a multiple choice test, they're going to give you that as an answer choice. But that answer is not true. Now, this is not dealing with the idea of amount times cost per unit equals total cost. What is this dealing with? Nolan?
QRT.
Yeah, this deals with that formula, distance equals rate times time. But remember, we write it this way in our chart, because it's that D column we're going to use to solve this. So I'm just going to call it first part, second part. And basically what this problem looks like to me, and then the last would be whole trip, not mixture, is that the guy was on the freeway for the first part of his trip. Then he had to go either on side streets or a windy road. You know what, I'm going to erase this and move it out of the way. I'll do it in a different color, make it stand out a little bit. And it slowed him down until he hit his destination. Okay? So again, just like in the other problems, the last one, we know all the information to fill in for the first part of the trip. He traveled for 4 hours, going 80 kilometers per hour. The distance he traveled was 320 kilometers. He traveled for 1 hour, going 40 kilometers per hour, for a total distance of 40. Now we fill in for the whole trip. What was his speed during the whole trip? That's what we're trying to solve for. How long was he on the whole trip for? Yeah, we just add the 4 plus the 1. So his distance was 5x. So again, we're going to take the information from this last column to create our equation. And I'm going to again use that symmetric, put him in the left side because he's the only guy with a variable. And I get 5x equals 320 plus 40. So continue solving, I get 5x equals 360, and then I divide by 5. Well, 5 goes into 36 7 times, which is 35, with 1 left over, and 5 goes into 10 twice. So when kids falsely just add up the rates and divide by how many rates they added, they're not getting the average because he spent the bulk of his trip going 80 kilometers per hour. So it makes sense that his rate is going to be closer to that. Okay?